Yeah, we just find out that God is some underpaid programmer. He's just like, speed of light, screw it. That's as fast as things can go. I don't care anymore. We're all just in some game made by Electronic Arts simulating the 21st century. Well, I have been referred to as the God Emperor, but that was just because of my impeccable strategy in a few online games. Or just because I'm arrogant enough. But yeah, that's going to be one of the cool things, right? Is, we're going to just have little bacteria spitting out whatever we want. Have E. coli producing spider silk and spinning steel for us. It'll happen. So where were we? Right, raycasting. I don't really remember, because it's been quite a while. But basically, if anybody saw this big diagram here, basically back in January, I did a bunch of stuff here, but it's been, since frickin' January. Because I did a bunch of stuff with setting all these things up. And I did a bunch of physics work, so I probably still have it in there. So let's go take a look and see if I've already done this work. Yes, it's more green now. Yeah, a lot of the stuff, if you're curious about what we've been kind of working on here, a lot of the stuff we've been working on is just nuts and bolts, like starting with the announce back on the middle of March. We had to set up a bunch of websites, and just that takes time. It's not like any of that stuff comes for free. We're not like dealing with external contractors for these things. We're kind of on a budget, so we want to make sure, not only is our stuff secure and set up properly, but also pretty cheap. That was the last blog post. Like, we spent a bit of time making sure that we'd be able to keep running all these sites, and if things got popular, that we'd be able to scale them up, do all that stuff. So for the past, like, I'd say 3 or 4 weeks, at least for me, there hasn't been a whole bunch of progress on the actual game, like code. So I'm kind of getting back into it. No subs. Because I've been working on like just all this stuff that's around it. And then I had to go do taxes, and taxes are always awesome. Guess I should make the announce green. We did that, right? We announced. We're like a thing. We're like a game. It's gonna happen. And I'm helping Adam migrate his Bitey Castle site, which is, it's actually kind of funny because that's how Adam and I kind of met in some ways. Is like when we were back at EA2D, like I was just an engineer. I didn't do anything. And so I think maybe we saw each other a couple times. We didn't say any more than like 2 words to each other. Because I was just working real hard. I was actually brand new in the game industry, so I was like that little young guy in the corner, just like monkeying around on the keyboard, have no idea what I'm doing. And so I didn't go to any of the important meetings. Let's just put it that way. And actually, Adam needed help with his site a couple of years later, and I had friended him on Facebook for some ungodly reason. I don't know why you would ever friend that guy. And I was like, hey, I'll help you out. So kind of we met in some ways by me just like volunteering to like fix all of his crap on his server when it had exploded. So, and then kind of our getting started and working together is just another of just like, I saw him posting stuff online and was like, oh, hey, yeah, Adam. I remember Adam. I helped him out. Like, let's go see what he's doing. And then it somehow turned into us working together on the game, which is a miracle. Like, I have no idea how it happened, but it happened. Anyway, so let's go ahead and double check here with our other stuff. Looks like I got ray tracing in here, but let's just see exactly how it works. Let's refresh our memory of what we were doing back 4 months ago. So what it's going to do is it's going to sweep multi by channel. So we are going to sweep multi by channel. So we're calling that on the world. So let's pull up the F world documentation real quick, because I'm not an Unreal crazy dude, so I need to read docs. So what do we got? We're calling sweep multi by channel. Sweep a shape against the world and return all initial overlaps using a specific channel if requested. Then overlapping hits and then first blocking hit results are sorted. So a blocking hit will be the last element of the array. Only the single closest blocking result will be generated. No tests will be done after that. So ray trace direction is going to give me the hits that have happened, but it's going to go up until it blocks. And all these sweeps are by collision channel. And we've got all these collision channels that we got here. So sweep against the world and return all using a specific channel. Okay, so we're going to sweep as a specific thing, and it's going to hit. So what's in an F hit result? Structure containing information of one hit of a trace. I'm seeing if we get the We get the physics material and some basic stuff about it. Do we get the collision object? I don't see a collision object. I guess we get the actor. And does the actor have the channel type on it, or is it like the component? Yeah, so we're gonna have the primitive component. And does the primitive component have collision channel? Yeah, so the component on our hit is going to have the collision channel. So that's just going to be the thing that we actually hit. I'm going to write all this crap down so I get it. Okay, so ray trace returns the first blocking hit. The trace based on the channel that you cast. So you hit all blocking channels for that channel. The component that you hit actually tells you what object type it is. So let's see what I even set up here for the collision channels real quick. Make sure they're actually set up in some sort of regular fashion that makes sense. Because I've got all like the different things. Let's make sure that like the we're gonna want to cast player body against terrain. So we're gonna want to make sure that terrain actually like is a blocking hit for our ray. Where is it? Project settings? Like I thought it was. Let's Google it real quick. Yeah, so it's project settings collision is where we are. So let's see what we got set up. So we want to check we got the player channels. I guess we can't scroll down for some reason here. There it goes. Alright, so when we select one of these guys, player body, yeah, this UI is just garbage. So player body, if we're going up against terrain, it's going to block. environment body is going to block. Player body is going to block. Enemy body is going to block. Okay, so that's good. We can't penetrate enemies. We can't penetrate bodies or environment. So let's see. Is this what we want? I think so. Like, so we can walk on anything that so we could walk on enemies, we could walk on players, we could walk on environment stuff and terrain. And enemy passable terrain and destructible and all the rest. So that's looking alright. So if we cast as player body, we'll be able to do that. Let's double check enemy body or environment body. Alright, that's looking proper. Seems halfway decent. So we should be able to do ray traces here then, and see if we can actually move in these directions. So let's try something real simple to start with. So our movement object is going to need a call ray trace. So let's throw this over here. So, where we've got our position here for our dude, we're gonna want to call well. How do we actually want to do this? Let's just do it really stupid to start with. Like, let's just assume everybody's a point. So we're just gonna ray trace a direction. Really, what we're gonna need to do is do like a sweep check against the world, and then we're gonna need to do like ray traces based on like, okay, well the Bitey's feet are here, so we need to know if he's on the ground. So we're gonna do a ray cast from his foot to the ground and see if he's there. So what we want to do is we want to see if we can move to that specific location. So what we're going to do is we're going to trace from our last position, and we're going to make this code real unoptimal. So we're just going to do current position equals get position, and we're going to wrap this up in a kind of a little block here. So we're going to need our direction. So the F vector movement direction is going to be pos minus current position. Let's call that something else, not just pos. Let's call it we don't even use this, so call it new position. So new position minus current position, and we're going to get the magnitude of that. So float. Yeah, we're gonna. Let's get the distance equals movement direction dot size, then movement direction dot normalize. So we're going to cast our position, so it's going to be current position, and we're going to cast in the direction of movement direction. I'm going to go our distance and E collision channel. Which one is player body? Player body is... Do I have a good lookup for these guys? I think I do. Yeah, here it is. ECC player body. That just defines it, so we're actually going to have to do it like that. And then we need a T-array of hit structures, is what it looks like. Alright, so hits. So this sweeps the shape. So return true if we hit anything. So we'll hit something. So if we hit something, then what we want to do is set our new position is going to equal current position plus, let's see, movement direction times the distance. So the distance is going to be a blocking hit will be the last element in the array. So we're going to want the hit results last equals hits sub hits.num minus 1. So we're guaranteed we actually have something in the array. So we're going to last.distance. So yeah, that's the distance we want to. So hit distance is going to be this one. So if we do this, we will, if we try to move into something, we will clamp to it and not go through it. So we shouldn't be able to go inside of that box now. So let's see if it actually does what it's supposed to. Or if we like get right on an object, that we just go right through it. Like maybe we need a little bit of an epsilon there because of math. Stupid math. What has math ever done? Nothing good, that's what. Alright, so if you didn't see that, because it's on the other monitor, we can move our guy around. Like so, but then we're stuck. We can't get out of it. I'm hitting the keyboard, and Fat Sack is stuck in the world. I can run all the way over here, and I'm stuck. So that's good. So instead of going all the way towards this, let's do a little bit of an epsilon. So let's make sure that we don't over penetrate these objects, so that we can move out of them once we've moved into them. So let's see, if last distance is less than penetration distance, then we will if it's less than it, then we will subtract. If hit distance is less than it, we want it to be if it's greater than. And we also want to check if our hit result was actually a blocking hit result. So if the blocking hit is false, then like it doesn't matter. And because we changed that global utility, we're going to have to compile all the things all over again. Alrighty then. So let's see if we penetrate this box still. This should just keep us outside of the things. And of course, I don't think we're going to have terrain that's moving, at least if we do. It'll have to be like another whole thing. Terrain that's moving. Yeah, we will have terrain that's moving. We'll have people, and if we can stand on people, then do it. Yeah, so here we can no longer penetrate the box and get stuck. It's just so good. Raycasts look like they actually work properly. Well, let's see if our animation stuff works properly as well. Let's double check it. So our movement object is going to need to access our animation controller. So, set our virtual controller. Where's this? So we've got the actor, but we're going to want that animation controller component. So where in the hell is that? There it is. So we need the animation controller. And we don't even set this to null. We should do that. What's the animation controller going to need from us? It's going to need animation ID. So where are these IDs? So we're going to need the entity. And we'll probably have stuff to clean up later here, because we don't need all of this stuff all over the place. But we're gonna do this for now. So yeah, we're gonna grab the entity, and the entity has get all animations for type. So we're gonna want an animation type. So we're gonna want to get all the animations for a specific type, and then we're gonna want to play it. So what I'm gonna do here is, this will be a hack for just a second here. But basically, we're going to get the magnitude of our velocity at the end of this here. So we're going to put this in another brackets. This is going to be setting the animation based on the movement. So what we're going to do is we're going to get the kind of the XY velocity. So sorry, I didn't see your question earlier. Can you reuse that raycast now for other objects? Yeah, it's testing against everything in the world. So if I threw another gray box in there, I wouldn't be able to penetrate that. It's like super naive though. Like, right, what I should be doing is I need to be sweeping all the collision objects for Fat Stack against all the world. I'm just kind of working one step at a time. Like, if Fat Stack was just a mathematical point and I wanted to move them around the world, I'm kind of doing that first. And then once I know that works, then I can start sweeping and doing other stuff and dealing with all the problems that happen with that. So just some basic stuff, because I might actually, instead of sweeping the parts of Fat Sack or another character that's running around, I might not, it's the collision with everything else needs to be really precise. Like if you're against a piece of geometry that's like this, you're going to want to you need to get put right on top of that and move properly along it. But what's not super important is that all of fat sack is perfect with that collision. So it may be that I'm using a bunch of ray casts. Kind of, if this is fat sack, I'm using a bunch of ray casts to determine if he's getting more into something or not. So he can kind of slip a little bit into an object and then then slip out of it and all that sort of stuff. So there's going to be a lot of things where maybe I'll have the collision geometry, but then I'll kind of see like, well, if his feet are on the floor and he's not going too far into something, then we can have a little bit more flexibility, because nothing's worse in a game than actual like good precise collision on a something like that. Like you're running along and all of a sudden there's a 1 pixel lip in the world, and your guy is like Godzilla, just slams into it, just bam, or just slams into it and stops, and you're like, what the hell just stopped me? Oh, it was a stick. I'd be like, come on, just step over it, like Jesus. So there's going to be a lot of little nudging and pushing stuff up and around, and it's not going to be simple at all. So we're going to start with simple. Mathematical points are simple. I'm just going to call this one speed XY. Not XY. What are our axes here? I need to stop working in reality and go. So Z is up and down, and Y is left and right. I should probably... Yes, I've experienced. I think we all have. Like, if there's one constant, it's like that stuff's been crappily programmed. Anyway, I'm going to go right down a little. I'm going to draw myself a little picture and stick it on the wall here. Alright, so up and down is Z. So my wonderful picture. That'll let me know which way up is. I need to go get some tape and shove that on the wall. Yeah, my place looks like an insane person lives here because I've got like stuff taped up like scrawlings of character diagrams. I've got like Australia 7 hours behind me, stuff like that. Somebody must think I'm obsessed with Dashkin and entities in Australia. All right. All right. So our speed here is going to be. We're just going to do the current velocity dot y, and we're going to fmath abs that thing, so we know if we're actually if we're going at a decent speed. Um, let's just call it speed horizontal, and let's do speed vertical equals fmath abs and current velocity dot z. So we'll do something real simple here. So if speed vertical is greater than 0, we are going to want to do m entity get animations type, and we need an array of those. Animation. We need Dashkin animation type. Let's see. Let's get is falling. So air falling. At air falling. So if anims.num is greater than 0, we're just going to grab the first one. And then f animation controller play. How the hell are we actually supposed to do? Is there like some sort of get animation by type? Yes, I do need the red strings. I'll have like a map, like all the of Brackenwood, and I'll be tracking down, the hidden Nazi codes that the UU use. So let's see. We need that animation controller component. What the hell did I put on this? It's like everything's based on this animation ID, so I need to get the animation ID for an animation. So I've got get animations. Does the animation wrapper have where the hell did I stick that? This is the problem after you come back to the code after even just like a couple days. It's just like, where the hell is everything? Is it entity-data.h? There it is. So we have a unique name. We do not have an animation ID. Well, let's just go to the animation controller component and see what we've got. So set parent, rebuild. Rebuild is coming down here to the flipbook component, and it gets all the animations. And what is our ID? Flipbook, get unique ID. Okay, so we're using the ID of the flipbook component. So when we call play, we're going to do rep dot flipbook get unique ID, and alright, so and then we should be able to play our animation. So we're just going to call play with anim ID, and we're going to say don't interrupt. So every frame that we are moving in the vertical direction, we're going to say that we're falling, and we're not going to interrupt it. So else if speed horizontal is greater than 0, we want to get the idle animation, but I stored the idle animation in the idle state, but, well, this is one of the things I need to do. I don't have the animation dictionary for all the different states that we've got on this guy, so this is actually the AT idle state. And so we're just gonna, if is speed horizontal, yeah, we need to have another if else here real quick. And I think what we're gonna need to do is grab, it's one of these, I've got like the animation set, and I want to get this specific animation data, get entity animation data. Is that what I want? So I've got the animation stuff. We want to get animations for a specific type. Oh, whoops. Yeah, we don't need those. Get entity animation data. Is this really? Okay, so it's, we want to grab, actually, we want to grab this in a different way. Okay. So we're going to do m entity, yeah, so anim data. Let's just grab that up top here. Anim data equals, so we'll grab the animation data, and then right here we want air falling. So we're going to want anim data dot air falling, and then we're going to want to get, yeah, we're going to want to get animations for set. And that's going to, so air falling, and we want to get it for idle is the animation set, which is AS rest. And then this guy is, we're getting, this is going to be the idle, and we're not going to be at rest, we're going to be slow. So we should get our trundling fat sack on that one. And this one should be the AS rest. Now, this might seem pretty confusing. That's because it is. I'm still getting used to it. Does not have an overloaded number. Get animations for sets. It's like, what's it complaining about? This isn't a pointer, it's a reference. So our base getting the slowest air falling animation that's available. This one is grabbing the a slow, so not the slowest, but a slow idle animation. So he's moving slowly, which means he's walking, and he's not doing anything when he's walking. So he's idle while being slow. And this one is idling at rest. So he's sitting there doing nothing, so he should do nothing. Well, let's see if this crap just like completely blows up on me, because I have not tested it. So let's just double check here. We're hitting our code. We are setting our animation here. So animation ID is there. We are not interrupting. And anim data is null, so we are not finding our animation stuff at all. So let's take a look. Why not? Our animation lookup is empty. Why is our animation lookup empty? It's on my finger. Oh, it's tape. No wonder. It's like, what the hell is this clear crap on my finger? So why are you empty? Well, let's go find out why you're empty. Well, let's just see if our rebuild is actually getting triggered. Alright. I like how Adam is probably like still totally asleep. So rebuild is getting called. So your flipbook component is null. It is. Let's. Is our parent null? Wait, what? Animation is empty. So the parent was not null. Is this what I wanted? No. If parent is null, then skip this stuff. Right? That's just wrong. This is what thing is. Like I've run a lot of this code, but I haven't run it. You know, you build. Excuse me. You build like tons of stuff in your engine, before it ever becomes actually useful. So like by the time you get to using like, alright, we've got this animation controller and all this stuff, you start finding all those little things that are broken in it. It's like just immediately as soon as you start using it. So it's usually that past me is an asshole and has totally screwed everything up. And we're just constantly fixing past me's mistakes. Let's just update our channel real quick. We are doing Unreal 4 animation and movement for 2D character. Dashkin, C++. Yeah, past me to future me. Yeah, sometimes past me is actually pretty cool though. Like, there have been times where I'm like, whoa, good job past me. But those are very rare. Oh, okay, so now we're actually getting some errors. So what is this guy bitching about? It's saying, unable to bind delegate to function may not be marked as a U function. So, okay, this was something that I had screwed up previously. Basically, when you're binding delegates, you need to make sure that the function that you're calling back on is a U function. So we're going to go make sure that our things down here are U functions. And this markup basically lets the Unreal 4 header tool know what's up. So it can parse your classes and do all the things. You can see like we got U properties and U functions and all these things. It basically lets the reflection systems know what's going on, and every time you make one of these files, actually, it generates this file. If I can open it here, so this is all generated code from Unreal. So it'll generate code based on that markup for you. So whenever you change stuff, it's generating a whole bunch of C++ for you, which makes it fast at runtime. And C++ doesn't have like built-in reflection like a lot of other things like C# and all the rest. So that's how they do that. I'm gonna have to write down. I need to change those names to match what Adam likes. Change names of animation sets to be stationary instead of rest. And I need Trot and the rest in there. Cause he's got like names for things like a normal person. Like if it was me, I'd be like animation set 0 on, animation type 5, and everybody knows what that means, right? And he's like, no, can we have like animation walk? I'm like, what? I mean, I guess if you wanna be like that, one of those people. Alright, so we got past all those angry things, and we're now going to build our lookups. And it looks like those are working properly. So now we're back in our movement object, and let's